Hello, this is Mrs. Taylor, and I'm going to show you how to solve by completing the square. And this problem is an example of everything combined into one. You have an a value that doesn't equal 1, so you're going to have to factor that out. When you factor it out, you're going to get decimals because 5 divided by 2 is a decimal. And then your answer is also going to be complex. It's going to have an I in it. So this is like the supreme problem. It's got a little bit of everything. So I'm going to walk you through it, hopefully go slow enough for you to follow. So the first thing I have to resolve is this 2. If I'm going to use completing the square, I can't have a number in front of my x squared term. So if I factor the 2 out, I would have x squared plus, and then 5 divided by 2, that would be 2.5x. And so now I've got my binomial that I can complete the square for because the a value now equals 1 instead of 2. And so I would divide the b value by 2. So 2.5 divided by 2 is 1.25. And if I square that, I get 1.5625. So completing the square would look like this. 2 times x squared plus 2.5x plus 1.5625. And remember, whatever I add, I also have to subtract. And I have a 2 out here. So not only do I need to subtract the 1.5625, but I need to subtract 2 times that. So multiply it by 2, you get 3.125, so minus 3.125 equals 0. I'm going to box this in so it doesn't get confused with the work. Okay, so now I'm going to replace this trinomial with the binomial squared and then combine the 7 and the negative 3.125. So that would become 2 times x plus 1.25 squared, and then 7 minus 3.125 is positive 3.875. And remember, we're following the same process. Even though we have these decimals, we follow the same steps. So I'm going to subtract the 3.875 from both sides, and I'm going to divide by 2. So that was the subtraction step. Divide by 2. And I get x plus 1.25 all squared equals negative 1.9375. All right, so at this point, I would take the square root of both sides. And I'm getting the square root of a negative, so I know that my answer is going to be complex. And don't forget your plus minus. And in order to finish, I need to subtract 1.25 from both sides. But from previous problems, I know it's a good idea to go ahead and convert to fractions because I need to simplify this radical. And I could simplify it at the end, or I can simplify it now. So 1.25, I'm going to do 1.25 math, enter my calculator. And I get 5/4. And then 1.9375 converted to a fraction is 31/16. And so what we know about simplifying radicals is I can take the square root of the top and the bottom separately. And so if I do that over here, the square root of 31, well, 31 is a prime number. There's nothing I can do with that. It's in the numerator, so it can just stay a square root. It doesn't have to be simplified. But I can't have square roots in the denominator of a fraction. And it's really nice because square root of 16 is actually a perfect square. That just equals 4. So this simplifies to the square root of 31 over 4. And so I can rewrite this as x plus 5/4 equals plus or minus the square root of 31 over 4. And then from there, I would break this into the two cases where x plus 5/4 equals positive square root of 31 over 4. and x plus 5/4 equals negative square root of 31 over 4. And when we are adding or subtracting radicals, usually we write the non-radical first and then the radical last. So I'm going to write this as x equals negative 5/4 plus the square root of 31 over 4. And I'm going to write this as x equals negative 5/4 minus the square root of 31 over 4. And in this case, whoever wrote this problem was really nice because they gave the solutions common denominators. So what you'll see is you can write it like this. This is correct, but a lot of times you'll see it as combined. So you'll see x equals negative 5 plus the square root of 31 over 4, and x equals negative 5 minus the square root of 31 over 4. And when the two solutions are so similar, it's just a difference of a plus and a minus, sometimes you'll see them combine into one. So what that means is they write x equals negative 5 plus or minus the square root of 31 over 4. So sometimes you'll see your solution written this way. And this is actually leading you into the quadratic formula, which we'll learn this coming week, because your solutions are going to look a lot like that. So that is a little bit of everything. And you know what? I think I just remembered throughout that entire process, I completely forgot that the negative 1.9375 was negative. So this whole time, I should have had an I out front. So I can go back and add that in. I just made the fraction negative, and then all I need to do is write a little I in front of my radical for each of these. So I, and then I need an I here. I'm glad I caught that. What I should have written was negative x equals negative 5/4 plus I square root of 31 over 4, and negative 5/4 minus I square root of 31 over 4. And so when I combine it, that I just stays there, and it would just sit there between the plus minus and the radical. Sorry about that. All right, so that would be how you would solve by completing the square when your answer was radical, which means it has a square root in it, and complex, which means it has an I in it, and rational, which means it's a fraction. So a little bit of everything.